All right, today we're starting with 2.3 real zeros of polynomial functions. We'll be spending 2 days on 2.3. We're going to first start looking at dividing using synthetic division, one of my favorites. Apply the factor and remainder theorems and factor a higher degree. Remember back in, I don't know, probably 3rd grade, 2nd grade, 3rd, 4th grade, we did long division, right? You look and go, 6, does 6 divide into 2? No, but 6 will go into 20 3 times. Then you subtracted. 6 times 4 is 24. 0, so then you bring down the 7. 6 goes into 7 one time. 13. 6 divides into 13 twice. You had 1 and you wrote it as a fraction. 1 over 6. The same principle applies to polynomials. We can divide polynomials like long division. Except for this time, whenever there's a missing variable, we're going to write it in as a 0x. We count down by the exponent, 3, 2, 1, and then the constant, which is negative 9. Now we say, okay, what times x will give me x cubed? It's x squared. I line up my x squared so I know where I'm at. So now multiply by distribution. X squared, or cubed, minus 3x squared. Well, what was the next step in long division? Next step was subtraction. So I subtract this whole thing. X cubed minus x cubed is 0. Negative 2 minus plus, so that just leaves me with an x squared. I bring down. Now, in long division, I always bring down the whole thing so I don't get lost where I'm supposed to be. X times y will give me x squared. Will be x. So now I distribute x squared minus 3x. Again, subtract. Now, what times x will give me 3x plus 3. Now will give me a 0 at the end. So when I take the polynomial and divide it by this binomial, my final answer is this trinomial. That's what I would get. But we don't want to use long division all the time. Okay, let's use synthetic division. It's a shortcut for dividing, but it only works when it's in the form of x minus k, not x squared or x cubed. It has to be x to the first. So if I'm looking at x to the fourth minus 10x squared minus 2x plus 4, and I'm going to divide it by x plus 3. Well, one thing you have to remember here is you divide by the 0. So what does x plus 3, what did 0? Well, x would then be negative 3. So remember we set up these charts in Algebra 2, and negative 3 was out here. So then inside are my coefficients of my polynomial. Coefficient on x to the fourth is 1. Coefficient on x to the third is 0 because it's missing. X squared, coefficient on x, and then the constant. Bring down the 1. Now I multiply, negative 3 times 1. Now I add, 0 plus negative 3. Now I multiply. Now I add, multiply, add, multiply, add. Because I started with an x to the fourth and I divide it by x to the first, that leaves me with an x to the third. So what's left in this row are the coefficients in my polynomial. This would be x to the third minus 3x squared minus x plus 1, and that would be my remainder, 1 over x plus 3. I can do the same thing. This time, what's my 0? In this second problem here, what's my 0? My 0 is x equal 2, so I'm going to synthetically divide by 2. My coefficient on x cubed is 5. I don't have an x squared. Negative 6 is on x, and then my constant. Bring it down. 5. Multiply. Add. Multiply. Add. Multiply. Add. Since I started out with an x to the cube, and I divide it by an x, this would now be a coefficient on x squared, so it's 5x squared plus 10x plus 14 plus my remainder over my divisor. And that's my answer. Let's look at this. Evaluate the function. We know how to evaluate this. We plug in f of negative 3. And then we substitute it in. Negative 3 to the 4th minus 10 times negative 3 squared minus 2 times negative 3 plus 4. Negative 3 to the 4th, 81. 9 times negative 10, negative 90. Plus 6 plus 4. Negative 9 plus 6 plus 4. Negative 3 plus 4, 1. Well, that seems to be a lot of work to me. So there's a theorem we could use. It's called the remainder theorem. If it's divided by x minus k, the remainder is r equal f of k. You can evaluate functions using the remainder theorem, which is evaluating using what's called synthetic. Okay, synthetic substitution. So if I want to use the remainder theorem or synthetic substitution, I already have what x is equal. X is equal to negative 2. My coefficients are 3, 8, 5, and negative 7. Bring down the 3, multiply, add, multiply, add, multiply, add. So what I can draw from this is that if I divided, I would have 3x squared, but I'm evaluating. So what I'm saying is that at f of negative 2, my function is equal to negative 9. You can do the same thing here. If I evaluate this at 3, it would be 1. My coefficient, negative 2. A 0 because I don't have x, and negative 9. Bring it down. Multiply, add. Multiply, add. Multiply, add. My remainder is 0. So at f of 3, my remainder is 0. So f of 3 is equal to 0. A factor theorem. Polynomial has a factor if and only if f of k equals 0. Remember we said if it's equal to 0 at the end, if the remainder is equal to 0, then that's a factor. So I can determine anytime I want if a given binomial is a factor of a function. Look at one. Okay, so we're going to evaluate, we're seeing if x minus 3 is a factor, so we're going to evaluate at x equals 3. My coefficients are 2, 2, negative 16, and negative 24. Bring down the 2, 3 times 2 is 6. Add, multiply, add, multiply, multiply 0. So since my remainder is a 0, I can conclude that x minus 3 is a factor, and or so x equals 3 is a 0 of the polynomial. And so let's test x minus 3 on this one. So again, I'm going to synthetically divide by 3. My coefficients are 3, 2, negative 19, and 6. Bring down the 3. 3 times 3, multiply, add, multiply, add, multiply, add. So what I can conclude about that, because this is not equal to 0, I can say x minus 3 is not a factor. So x equals 3 is not a 0. Now, what I can look at with like the next slide is I can look to see, is more than one factor a factor of the polynomial? So I'm going to start with x minus 2 first. So that would mean that then I would have to use 2, the 0, to see if it works. My coefficient is 2, 7, negative 4, negative 27, and negative 18. Bring it down. Multiply, add, multiply, add, multiply, add, multiply. Okay, so it's a 0. So yes, x minus 2 is a factor. So since I tested x minus 2 first, and it says show that they are, we showed that. Now let's look at show x plus 3. So I'm going to look at x plus 3. Well, what do I synthetically divide by? I'm going to synthetically divide by negative 3. But since x minus 2 is a factor, then x plus 3 has to be a factor of what's left in this box. Okay, so x plus 3 I can test on this part of the polynomial. I'm going to test it using the 0 of negative 3. Bring it down. Multiply, add. Multiply, add. Is it a 0? Yes. So x plus 3 is a factor. So I did step 1, show that they're factors of it. Awesome. Now find the complete factorization, which means I have to factor what's left. Well, this was x to the 4th. This was x to the 3rd. So this has to be an x squared. So I'm going to look at factoring what's left. 2x squared plus 5x plus 3. Now let's see if I can factor that. Factors of 2 are 2 and 1. So let's see. Factors of 3. 3 and 1. Okay, so that gives me a 2x. So I check 2x plus 3x. That gives me my 5x, my middle term. So I'm good with that. But it says write the complete factorization. Here are 2 of them. The other 2 are these ones. So those I also have to write down as part of the complete factorization. So there is the complete factorization of our original polynomial 2x to the 4th plus 7x to the 3rd, etc. Next directions, factor completely, or give the complete factorization of the polynomial, given that x plus 3 is a factor. It's telling me it's a factor, so when I do my synthetic division, my remainder better be a 0. It's telling me it is a factor. Again, I put the 0 in because the x squared term is missing. Bring it down. Multiply. Add. Multiply. Add. Multiply. Add. Okay, so x plus 3 is a factor. It told me it was, therefore my remainder better be 0. Since it started out to x to the third, now I'm going to look at x squared minus 3x minus 10. See if I can factor this. This factors to x minus 5, x plus 2, but that's only that piece. It says a complete factorization, so I have to take this x plus 3 and write it down here. That is the complete factorization of x cubed minus 19x minus 30.